Hello everyone and welcome to Professor Panda. And in this video we are going to go over the chain rule. Alright, so what is the chain rule? Here is an example of when you can use the chain rule. Let's say that you have two functions, one of which hypothetically would just be f of u. So you have a function f, which is a function of the variable u, and then you have a second function, u of x. So you have the function u, and it's a function of the variable x. And then when we combine the function in the following form, f of u of x, we have a function in which we can actually use the chain rule in order to take its derivative. So let me go ahead and give you guys an example of the type of function that we would actually see where we could apply the chain rule. Let's say we wanted to take the derivative of the following function. So taking the derivative of 3x squared, make sure that this is legible, 3x squared minus 2, and we're going to raise it to the fourth power. So here what we have are, this is one function, but we could actually rewrite it as two functions. So in this case, our f of u could be looked at as this. F of u is equal to u to the fourth. And our u of x is basically what's on the inside. So our u of x is a function of x, and that's just 3x squared minus 2. And these have a name. So the f of u is the outside function, and our u of x is the inside function. Now, in order to take the derivative using the chain rule, we use the following formula. So let's say we want to take the derivative of f with respect to x. So we want to find df dx, and that's going to be equal to the derivative of f with respect to u times the derivative of u with respect to x. Now let me go ahead and solve for these two separately. I think it's a little easier to see that. So this is our f of u. So if we want to take the derivative of f with respect to u, this is just a basic polynomial function. So our derivative of that would just be, let me write that out, df du, which would just be 4u cubed. And then let's say I want to take the derivative of u with respect to x, and that's another straightforward derivative of a polynomial expression. So du dx, and that would just be, okay, so we start here, move the 2 in front, we get 6x, and then we would have 0 because the derivative of a constant is 0. So in order to clarify this too, we've written it in this way where we have this function of u, and then we've written u of x as being this expression. So then we can basically substitute this value, this function of u, back into this value of u right here, so that we get 4 times 3x squared minus 2, and then raising to the third power. There we go. And now we have our df du, and all we have left to do is actually multiply them together. So once again, our df du is going to be 4 times 3x squared minus 2 cubed times du dx, which is just 6x. And we can go ahead and simplify this. We have 4 times 6, which is 24, and we still have an x, so 24x times 3x squared minus 2 cubed. Okay, and this right here is going to be our solution for solving for the derivative of this function, 3x squared minus 2 to the fourth, using the chain rule. So this example was really straightforward, and it used very basic polynomial expressions or polynomial functions, but the chain rule can be applied to any function. So I'm going to do another example here. So if you want to just take some time, look at this, copy it, do whatever you have to do. I'll erase this in a second, and I'll do another example using a trigonometric function. Okay, so here we go. Okay, guys, welcome back. Okay, so let me do another example. So let's say we want to take the derivative of the following function. Take the derivative of cosine of 4x, and we want to raise it to the 4th power. So remember that generally when we write trigonometric functions, it's common notation to write the power in the middle right here instead of on the outside. At least that's what I see most often, but I'm sure if you put it on the outside, that's not wrong either. Okay, but now let's break these apart now. So this is actually really similar to the last problem that we did. Okay, so once again, we have a function, our outside function, f of u, and just like last time, our f of u is actually the same. We have u to the 4th, and then we have an inside function, u of x, which is actually going to be cosine of 4x. Okay, so let's go ahead and begin. So once again, the chain rule, and I'll write it again just for reference. So df dx is equal to df du times du dx. So in this case, let's look at our derivative of f with respect to u, same as last time. We're just going to have 4u cubed. And now let's look at our derivative of u with respect to x. So if we look at this, this is actually interesting because what we have here again is a function where we're going to need to apply the chain rule again. And that's actually not uncommon when using the chain rule, is you might decompose the function into an outside and an inside function, and then you realize you can keep applying the chain rule to the inside function, and you just keep going until you get your final derivative. But in this case, we're just going to have to use the chain rule one more time. So here our outside function is going to be cosine, and then our inside function is the 4x. So let's go ahead and we're going to take the derivative of, begin by taking the derivative of our outside function, which is going to give us negative sine of 4x, and then we take the derivative of the inside function. The derivative of 4x is just going to give us 4. And just again, like last time, I have this value for u of x, which is equal to cosine 4x, and I can just write it back into this value of u right here. So this is going to be 4 cosine 4 parentheses, so it's legible, 4x. Okay, there we go. So once again, all I need to do now is just multiply these together. So derivative of f with respect to u is going to be 4 times cosine 4x times, now derivative of u with respect to x, negative sine 4x times 4. There we go. And now we can simplify this. We have 4 times 4, and we also have a negative, so bring that to the front. So we have negative 16. Oh, and let's not forget one more thing here. I almost forgot, there's a cubed. Okay, that's still part of this expression, and the cubed goes right here. Sorry about that. So we have 4 times cosine 4x cubed times sine of 4x. And there we go. Once again, we've used the chain rule to take the derivative of this function. And I just wanted to give another example using trigonometric functions just to see that it's the exact same concept. So I just want to say thank you guys for watching. Hopefully this helped. If you guys have any questions, I would love to read them in the comments section or any general comments you guys have. But once again, I hope you guys enjoyed this video. Have fun learning, and I will see you next time. Take care.